as we described developing a use case, what is the actor? So actor is a person, one person, device, or a software that does something called functionality. So user can play a number of different roles. So it's not that one person is always one actor. So one person or one user might have different roles. So every role or every that is a actor. So what are the main tasks or functions that are performed by the actor? So you say that in a function, what are different actors and what they can do and what they cannot do. So system information, for example, once you have it, answer to all of these questions, for example, what we just described earlier, then you can create a use case diagram. So use case diagram is the UML model. So it uses the graphical representation. As you can see the questions themselves, there are many questions, and if you try to describe them in the text, then it is not that you cannot describe it. Yes, you can describe it, but it is very heavy text documents. So with the diagrams, as normally we say that one diagram is worth of 1,000 or 10,000, really depends on your diagram, worth of words. So overall, UML or use case diagrams are the UML model, unified modeling language, where we try to graphically show the use cases and their relationships to different actors or the different processes, functions. So UML language, the standard for diagrams and terminologies developing for information systems that we discussed a bit about the UML in previous lecture. So actor in the UML is the name for the end user. So automated boundary is a boundary between the computerized portion of the application that user who operate the application. That is automatically when you create a diagram and attach the actor to a functionality or a process, that means that actor can do only that specific part or that function. So for example, here use case diagram symbols. So this is the actor. So this is a symbol for the actor. So this can be a shipping clerk. So actor is a stick figure of a person. So usually meaning an actual person using the system, but that can be the other process. But normally we do represent the processes with the oval. So connecting, then we have the line. So this represents that this is a person, shipping clerk, that ships the item. So automated boundary. So overall, so this is a process doing the shipping or shipping the actual product. So that means shipping clerk can do, so in this box we have shipping. So if this actor or shipping clerk can do the other application, then we have to put a oval here. For example, we say collecting payment. If we just say that shipping clerk also can collect the payment from the user, so you just put it here. But here is just describe that this is the actor, he can do this. So this is really a system boundary. So this means this actor, shipping clerk, can't do much, just the shipping, right? So for example, use case diagram, and another example, here we have the homeowner, here we have the system administrator, here we have the sensors, right? So sensors are the devices, right? So say homeowner, arm, disarm the system. For example, if there is an alarm system, so access system via internet, so he can do all these processes. So we say that this is an actor, he can do arm, disarm the alarm system. He can access via, so when you're doing arm or unarm, turning on or off your home monitoring system, or accessing via internet, that is a process that the homeowner can do, respond to an event. So for example, this, now see here, the sensors doesn't put a role. So it's not that those sensors will be activated or disactivated, but only user can do it. When he want to see it, he can see it. But in this process, you note that there are two actors, or the other system here. Not the actor, but this is a person. As we say normally, actor is a person, respond to an alarm event. But in the alarm event, the sensors, say camera or motion sensor, or the voice sensor, or humidity sensor, or heat sensor, or smoke sensor, all these sensors, they feed into this information. So for example, when an event is generated, and after that, when the user is responding, so he can access those resources, the sensors, or he can activate them or deactivate them. So in this process, two actors in a way are involved. Similarly, encounter an error condition. If there is an error, so how to fix it, turn on, turn off. Again, in this process, two actors are activated. So we really create diagrams like this if there is something to describe our software functionality. So for example, if you can imagine, if you want to, or if you are given a task to describe this system, you can imagine how much text you need to describe. Rather here, it's easier. Okay, so reconfigure sensors and related system features. For example, this system is built, so system administrator or a technical person, they can install, update the sensors or system configuration the way that sensors interface with the system. So a homeowner doesn't do that. So that is a special system administration. So this is a normal user, homeowner, and maybe technician or system administrator who can do that. So see, different processes, not necessarily all processes need all actors. So here, the boundary of this actor, so every actor's boundary you can see clearly. Say system administrator can't do these things, or he's not allowed to do it. It's for the homeowner. Similarly, for the homeowner, the boundaries. And overall, this is the boundary of the system. So that means if there is anything which is not related to these processes, it's not part of the system. And these could be, say, if we call these functionalities or the processes of the software application itself.
The Victorian Institute of Technology has other great videos covering many different topics. Please check them out, and thanks for watching. Remember to like and subscribe the video for more great content like this.